Today's class, you know that we have discussed on this particular thing called corrosion or rusting. So with this picture we will try to understand what is going on here. So this is your iron block or iron rod or nail or whatever you want to call it. So as I told you, this is iron, and you know electron configuration of iron is 2, 8, 14 and 2. So how the atomic structure of iron looks like? You have two electrons here in the first shell. Then you have it will not fit here. Let me draw it here. So you have two in the first shell. Then you have 8 electrons. Then you have 14 electrons. 1 2 3 4 5 6 7. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14, and then you will have your fourth shell in which two electrons will be there. So Fe will try to lose these two electrons. Okay, lose this two electrons. Why? Because if it loses this two electron, it will erase this shell completely, and from n is equals to 4 we go to n is equals to 3, which is lower energy state, because as you know n is a quantum number which corresponds to energy. So we are at lower energy state, so that is good for a particular element if it can come to a lower energy state. So here this is the same thing happening. Fe is losing electron. So how it loses the electron? So Fe loses the electron like this. So if it is losing 2 electron, it will be 2 plus, because as we lose electron the element becomes positive, 2 electron, and this reaction is happening here. So that's why we will call it anode. And why we call it anode? Because anywhere where electron loss is happening, the traditional name of that particular thing, or from where the electron loss is happening, is anode. So anything that will be losing electron will be called anode. So at anode we have electron loss. And what is electron loss? Electron loss is oxidation, because we know oil rig, oxidation is loss and reduction is gain. So this is what oxidation is happening. Now you have this Fe2 plus. What about, as we know in redox reaction, two things happens together: oxidation and reduction, because we have to balance the charges. So now we have to have reduction, but we have to worry about this 2 electron also, from where it will go. So if you can see from here, this 2 electron will travel from here to this water droplet. So this is water droplet, which can be like a moisture, a humid environment, or you put your iron rod in the glass of water, or it is like a ship is there inside the sea water or something like that. So it's a humid atmosphere. So here for illustration purposes we are choosing a water droplet. So water droplet will be made up of H2O, as it is there, but we are seeing this 4H plus. Why we need this 4H plus? Because this 2 electron has to travel in the water. Why they want to travel in the water? Because they want to move, as electron has movement. So this 2 electron wants to move, and for their movement we need electrolyte medium. What I mean by electrolyte medium? Something that has ions in it. Ions or charges. Okay. Electrolyte medium is something which has ions or charges. So now, as you can see in this picture, we have this 4H plus here. But now the question comes, from where this H plus is coming. From where this H plus is coming. So from where this H plus is coming? So we know in our atmosphere CO2 is present. So what happens? H2O reacts with CO2 to form H2CO3. Now you will ask why they are reacting. Why anything reacts? To make a more stable compound. But sometimes there are instigators that makes them react. So in this case there are few instigators that for now you don't need to worry about, but just remember that H2O reacts with CO2 to form H2CO3, and this H2CO3 is very weak and unstable, as also described in my PPT. So this H2CO3 is always try to partially dissociate into H plus HCO3 minus ion. Now you don't have to worry about this HCO3 minus ion. It can go in atmosphere. We don't worry about that. That's not your worry. You have to worry about this H plus. So now we have a electrolytic medium. So this makes the water droplet electrolyte. So as now we have electrolyte, electron can flow. So now this 2 electron can flow now inside this droplet, because we have electrolytic medium, because we have H plus and HCO3 minus ion. So now these two things happen. Now coming back to again this particular thing, we have figured out that this is our oxidation reaction, and now reduction has to happen. So reduction is what? Let's talk about reduction. Reduction is what? Gain of electron. So here what are the things present? So first we have this H2O, we have this H plus ion, we have this O2 which is in the atmosphere. So H2O will not react, but H plus combining with O2 will react in a reduction reaction. So we have O2 plus 4H plus 4 electron gives you 2H2O. So now you will tell that why you are making H2O again. H2O was there, but we are making H2O. Why we are making H2O? Because if you see this reaction, H2O got converted into H2CO3 and then got dissociated into H plus and HCO3 minus. So this H plus ion is again combining with the oxygen present in the environment to form H2O ion. But why we needed this H plus ion? We didn't made it. Nature has made it. So nature needed this H plus ion to have the movement of electrons. That electrons were released from the Fe. Okay. So this is the whole thing. So now we have our reduction reaction. We have our oxidation reaction. So whenever you have oxidation and reduction reaction together, oxidation and reduction reaction together, they will always be together, always. Okay, you need to get combined reaction. Okay, you need to get combined reaction from them. So now again revising the concept of half reaction, how do we get this combined reaction? So the easiest way to get the combined reaction is first write your oxidation reaction. So I am just writing oxidation like this, oxy. So what is my oxidation reaction? Fe loses 2 electron and it looks like this. What is my reduction reaction here? We have O2, we have this 4H plus that is coming from the CO2 thing. When water reacts with CO2 form carbonic acid, then it forms H plus ion and HCO3 minus ion. So from there this H plus is coming. Now as we have 2 O2, so one O2 needs 2 electron, so 2 O2 will need 4 electrons. So let's take 4 electron and it manufactures 2H2O. You can write gas here or liquid here, but for now onwards let's keep it like that way. So first of all, when you want to make a combined reaction, first target should be get rid of this electron number. So how we can get rid of this electron number? So the best way to get rid of this electron number is make them equal. So here I can see 4 electrons are there, so here I can see 2 electrons are there. So I will try to make this 4. So let's call it equation 1 and equation 2. So multiply equation 1 by 2, because if I multiply by 2 I'll get 4 here. So if I multiply by 2 I get 2Fe 2 plus 4 electron. Now again writing my oxidation reaction, O2 plus 4H, reduction reaction, sorry, 4H plus 4 electron gives you 2H2O. And now best way to get the combined reaction, so first we'll try to make the electron number same, like here 4, here we also try to make 4. And then once you have the same electron number, just add the LHS to LHS. So LHS of equation 1 plus LHS of equation 2, now make them 1, make them let's say 3 and 4, new equation. So LHS of equation 3, equation 4, don't do this, you will get confused. Just LHS of oxidation reaction plus LHS of reduction reaction, then RHS of oxidation reaction plus RHS of reduction reaction. Okay, so now what should I do? What are the things that are in LHS of my oxidation reaction? Write them 2Fe plus what is the LHS of reduction reaction? O2 plus 4H plus 4 electron. We are done with the LHS, then put the arrow. Then what is RHS? First RHS is this, so 2Fe 2 plus 4 electron. And what is my RHS of reduction reaction? This is my RHS of reduction reaction, 2H2O. So now you can see this 4 electron is here, 4 electron is there. You know, when we will bring it this side, it will become in minus. So we can directly cancel them because they will turn into 0. So what I get, 2Fe plus O2 plus 4H plus gives me 2Fe 2 plus 2H2O. So this is what my combined reaction looks like. This is my combined reaction. Again, let's revise how we got this combined reaction. So first we had our iron rod like this, and we know iron has a tendency to lose electron, so it lost 2 electron, and that happened at anode. And then this 2 electron has to travel, so they will travel through electrolyte. So how we make the electrolyte, or how nature makes the electrolyte? So we have H2O, it reacts with the CO2 that is present in the atmosphere, forms H2CO3 which is weak, and then this H2CO3 dissociates into H plus and HCO3 minus. Now we have our ions, so we have electrolytes. So this 2 electron of Fe will travel through them, And now as we have H plus, we have O2 in atmosphere, so reduction will happen at cathode, because it's always like that, and reduction is gain of electron. So O2 plus 4 H plus ion, which is coming from that CO2 thing, and then we add 4 electron, because reduction is gain of electron, we get 2 H2O. And then what we do, we know to get the combined reaction we need to add oxidation reaction and reduction reaction. We apply the step where we try to make the number of electrons same in both the equations. So we multiply this equation by 2 and then we add. So how do we add? We take the LHS of oxidation reaction, we take the LHS of reduction reaction, we equate it with the RHS of oxidation reaction and RHS of reduction reaction, and then we do everything and we got this combined reaction. So what's the aim of doing all this thing? I think in class also you had this doubt. So the thing is, we are trying to understand the chemistry of corrosion. And why is it so important to understand the chemistry of corrosion? Because you can apply it to any other phenomena where corrosion is happening. Let's say you are in an industry working as a scientist, and you get this problem that you manufactured like a machine which is made up of some material, and that material is getting destroyed. So you need to understand what is the chemistry behind it so that you can protect it. Because in 1700 the ships were getting destroyed. Maybe I'm not right with the history, but just for example, ships were getting destroyed by corrosion. So they were not able to figure out how to prevent that. Then they understood the chemistry, and then they understood that if the moisture is there, then the rusting will be more. So if rusting is more because of moisture, so how we can prevent them? So they started to dwindling on that, and then they come up with the thought that let's code them. So once you understand the chemistry, then only you can find out the solution. That's why it's very important to understand each and every step. And once you understand this right now, you can replicate this step for other scientific processes or investigations. I will give you that in assess prep test. So now we got this combined reaction, but still if you see in this combined reaction, the particular thing, this is still unstable thing, because Fe2 plus is an unstable product. So it will further react with the oxygen that is present. So I can write 2Fe2 plus 2H2O plus oxygen. It will give me something. Now in class I may have rushed this particular step, but let's try to understand it very clearly. So now this Fe2 plus needs to come with oxygen. So if you say in one oxygen how much charge it possesses in compound or oxidation state, what is the oxidation state of oxygen? It's -2. So right now how many are there? So if you say 2 to 4 are there, so we need -8 charge, means 4 multiplied by -2, so you get -8. So -8 thing is there. Now we have Fe2 plus, but if this Fe2 plus wants to react with O2, it has to lose one more electron. Why it will lose one more electron? Because it's a transition metal. It will try to lose one more electron, and it will try to bond with oxygen. So if this will lose one more electron, so Fe2 plus will become Fe3 plus electron. So now we have 3 plus here and we have -8 here. And you know, if we want to make a compound that has charge 0, so we have to equate this. Means +3 needs to equate with -8. So we need to have them in sync. So now it is +3. So this number has to be multiple of 3, then only it's possible. So now if you know, we had 2 oxygen, total 4 oxygen. 4 oxygen were there. Listen to it very carefully. We had 4 oxygen. We had -8 charge because one oxygen had -2 charge, and to bond with oxygen, this Fe2 plus needs to lose one more electron. If it loses one more electron, the charge that it will possess is Fe3 plus. So I have Fe3 plus as plus 3 and minus 8 here. And for neutral compound, I need charge to be 0, which is a stable compound. So if I want to make charge 0, this needs to be minus 8, but that is not possible. But can we make this as a multiple of 2, multiple of 3? There is a way. If I multiply, if I put 4 here, let's say, rather than 2, before it was 2, so rather than 2, if I put 4 here, then how many oxygens I will have? 4 plus 2, so I will have 6 oxygen. So 6 minus 2 will give me how much? Minus 12. Okay, 6, yeah, minus 12 roughly. So now I have to have plus 12 here. So I will get minus 12 as I have done 4. So 4 oxygen and here 2 oxygen. So total 6 oxygen. 6 multiplied by minus 2, you get minus 12. So here minus 12, here plus 3. Now if I have plus 3, can I convert it into minus 12? Yeah, by multiplying it with 4. So rather than taking 2 Fe2 plus, I can take 4 Fe2 plus. So I can make, because 1 Fe2 plus will give me 3 plus, and if I have 4 Fe, so it will be multiplied by 4, so it will give me plus 12, and plus 12 will be good for me. So that's why this 4 will come here and it will make a compound called Fe2O3. Now you must have a question, why 2 here and why 3 here? Because it has plus 3 valency and it has minus 2. So if one compound of Fe wants to bond, it can bond with 3, because plus 3 minus 2. So multiplied by 2 you get 6, multiplied by 3 you get minus 6. So that's why 2 and O is 3. That's how you decide what will come here based on the neutrality of the compound. And right now there are 2 Fe and 3 oxygen. So how many oxygens we had here? We had 4 plus 2, that is 6, and 4 Fe. So can I do 2 Fe2O3 plus what will be there? Now only H is remaining. So 4 multiplied by 2, 8 H plus. Now again you can check the balance. So we have 4 Fe, 2 multiplied by 2, 4 Fe. We have 8 H, we have 8 H plus ions. We have 4 plus 2, 6, 2 multiplied by 3, 6. So this is your final equation. It will look like this. So now you have got this compound called Fe2O3, but still it's not the rust that you see on your iron products. Okay, this Fe2O3 will again reacts with hydrogen oxide, means water, and I put X. X is nothing. It can be H2O, it can be 2H2O, it can be 3H2O, like that, NH2O. It can be anything. N can be, let's say, 10 or somewhat like this. And they make a compound called Fe2O3 dot XH2O. Abhi Arish has asked in the class why it's not plus, so it was plus here only. Plus doesn't mean one compound. This is one compound itself. Okay, so this is how it is done, and this is what your rust is. This is what your rust is. Watch this video again and again. If you don't understand, go step by step. You can rewind it now, as it will be on a YouTube. So see, and if you need anything or if you have question, you can comment. No, I will not allow the comments. You can just mail me or ask me in the lunch. Okay, see you, bye.